We're on? Okay. So we're doing lesson 3. We're going to be analyzing quadratics again more formally. And we're going to talk more about this quadratic formula here. That's this format that I showed you guys yesterday. Okay? So the first transformation we looked at was this one here. So note the letters that we use. Okay, so we're taking that original graph of y equal x squared and we're going plus q. That is a vertical translation, okay? Translation. Okay, so 2 examples of what happens. So here's y equal x squared in red. And then if we graph y equal x squared plus 2, it's a positive sign, so that moves the graph up. And I would add 2 units. Okay, it moves the graph up 2 units. So you can see the transform one is the dotted one. All the points, if you track some points, they all just move up 2 units on the y-axis. Okay? And we saw that yesterday. Once again, the graph in red over here is y equal x squared. Right there. And the transformation we're doing is down here. So if you go y equal x squared minus 3, so it's a negative sign, so it moves the graph down and just add 3 units. Right, and we saw this yesterday. We did a bunch of examples, so I'm just going to kind of go through it fast. Okay, really quick, check out the vertex. 1, 2, 3, there it is. Check out this point here, 1, 1. 1, 2, 3, there it is. So everything just shifts down 3 units. Okay, easy peasy lemon squeezy. Excellent. Next slide. All right, trickier. When we put the transformation in the brackets with the x variable and you square it, some weird stuff starts to happen. Okay, so yesterday we saw that this was a horizontal translation. Okay, so it's a horizontal translation, and it always moved in the opposite direction of what you'd sort of expect. Okay, so well, let's just look at the example. So here's the original graph, y equal x squared. Am I so awesome the screen is shaking? So there's y equal x squared. The particular transformation we're doing here, right here, so y equal x minus 2 in brackets squared. Okay, so it's a negative sign, which actually pushes the graph to the right. Okay, so it says negative sign, the graph moves right, and I would just add 2 units. Okay, so if you track, say, the vertex, you can see it goes 1, 2. Okay, so horizontal translations change the x values. Okay, so horizontal translations are changing the x values. You apply this transformation to the x values only. Okay, so 2 units to the right. Look at this point, 1, 1, 1, 2, 2 units to the right. This point over here, that's at -1 for x. 1, 2, it's right there. Okay? So everything goes 2 units to the right. Good? Quick question? Oh, you're just making hand signals? Excellent. Good. I like it. I like it. Let's look at this example. So y equal x plus 3 in brackets squared. So positive sign moves it to the left. So it moves left and just add 3 units. And then we can check on our graphs. So here's the original graph. Y equal x squared. And if you check out the vertex, it goes 1, 2, 3 units over that way. Check out this point, that's x equal 1. It goes 1, 2, 3, there it is. Okay, so everything's moving that way. So it always moves in the opposite direction you'd expect. Okay? So maybe just add moves in opposite direction. Then the sign. So then the sign on P. So moves in the opposite direction, then the sign on P. So if P is plus P, it actually goes to the left, like we saw here. And if it's negative, it actually goes to the right, towards the positive x values. You just gotta like memorize that, okay? It's just the way it is. Good, good, good. Okay. Ready? I'm just talking to an empty room, so. Alright, let me quickly grab my book. But yeah, we also looked at compressions and stretches. So the A value is the letter that we use for it. And if the A, now this one's a little bit more complicated, there's some cases here, but in the first example, if A is greater than 1, you're going to see what we call a vertical stretch, right? It gets stretched out. Or sorry, hang on. The graph is the image of the graph after a vertical stretch. Right. Sorry, we were calling this compression. And there. So here's the annoying thing. Some textbooks call it a stretch. And other textbooks call it a compression. So I personally like to call it a compression. So here's the original graph. And what's the equation here? Oh, right, it's on here. So for y equal 2x squared, okay, to me it's getting compressed. Does that seem to make sense to you? Some textbooks still don't call it a compression. And it drives me mental. And actually, we recently got some clarity on the grade 12 pre-calc exam. And I believe they went with sort of the silly way of doing it.
The stretch? So vertical stretch means.
Yeah, but I honestly, I can't remember. So for now, I'm just going to say it's not wrong to call this a compression. But there are different. There's no agreement on the language we use for this stuff. Okay? Because somebody was like, well, who cares what you call it? Like, we know what to do with the values, right? Like, we're going to multiply all our y values by 2. So then you have some textbooks that call it one thing and then textbooks that call it another thing. And they had to go with something on the grade 12 pre-calc exam. They just went with the wrong thing, in my opinion. Okay? Write your member of parliament. I really thought you guys would laugh when I said that. Well, that's what people use to shut down debate, right? Like, it's like, I noticed this thing that sucks, and people are like, well, write your member of parliament, and you're like, yeah, as if that actually changes anything, right? Hey. Right? Where it's like, oh, I don't like the prime minister, and then people are like, well, why don't you just run for prime minister? And it's like, do you know how much money they have to fundraise? Like, it's just not realistic, but anyways, not romantic. Okay. Last thing, if it's between 0 and 1. Okay, so the a value is between 0 and 1, so some fraction, okay, like examples like a half, a quarter, an eighth, maybe it's a decimal, right? But whatever, if that's the case, they call it the opposite thing, what I call it, they say that's a compression, so, and when you think about it, that also makes sense. But yeah, I call this a stretch. So here's the original, and it's like it's getting stretched out, but another way you can think of it is it's getting compressed closer to the x-axis, okay? So, how are we going to run this in the class? Like, as long as you said something like, oh, this is a vertical, I will give you guys some clarity on Monday. I'll go look at the grade 12 and I'll give you the exact language. We might as well use their language. Okay, so for now, I'm not too worried about how you describe it. So, if you say it's a vertical compression, by a factor of, and now this is what I can't remember, it's either a half, or because they kind of go with the opposite language, it's 2, which is the reciprocal. We will talk about it on Monday, okay? What I want you guys to know for today is what do? Is you take the y values and you multiply by what? You guys remember from yesterday, so for this one, if it was y equals 0.5x squared, what would I be multiplying my y values by? Yes, by 0.5. So for today, I just want you to walk away knowing, okay, if the a value is not 1, whatever it is, I'm going to multiply the y values by whatever the a value is to get my transformation, to get my new graph. We will talk about the language on Monday, because I'm just going to stick with what we do in grade 12. Okay? I just want you to realize that there are different ways of saying it, and it's really annoying. Okay, but we'll do the one that's in grade 12. Okay? I got kind of caught off guard. Okay, so I'll give you a moment to let that sink in, and then I basically think that we still got 2 more cases. Okay, so we saw this yesterday as well, so I'll spend a little less time here. Like if a is less than -1, basically just pointing out, well, you get a flip. You get a flip over the x-axis as well. At the end of the day, you still just take whatever the a value is and you multiply your y values by it. So if it was -2, I would simply take my y values and multiply them all by -2. Okay, check it out. So the vertex is 0, 0. 0 times negative 2 is still 0. That's why that point doesn't change. But if you look at the point, well, what's the scale on here? Okay, so it's going up by 2's, by the way. Like on here, it's going up by 2. On the x-axis, it's going up by 1. So the point 1, 1 is right there. So what is 1 times negative 2? Negative 2. So it goes right here. This is the point. Again, remember, it's going up by 2. So that's the point 1, negative 2. So you just take your y values, you multiply by the a. If you had to describe it in words, which you do have to do in grade 12 pre-calc, you could say, hey, so there's a flip or reflection over the x-axis, and then we'll talk about whether it's stretched or compressed. In my books, it's compressed. In this book, it says it's stretched vertically. In grade 12 pre-calc, not only do they want you to say what it is, they want you to say by a factor of. So we'll talk about it on Monday, okay? Yeah, it'll be fine. For now, I just want you to know how to do it mathematically. We'll talk about the English stuff later. Okay, what else have we got? Right, this is just from 0. So if a is greater than negative 1 but less than 0, then that's where you're getting the graph that I say is getting stretched out. So you get the flip, and then it gets stretched out. At the end of the day, you still just multiply all the y values by whatever the a value is. Do we get it?
Yeah. Yes.
Okay, so recap. We got vertical translations. What you see is what you get. If it says plus 2, move up 2. If it says negative 2, you go down 2. Then we have the horizontal translations. It's the opposite. If it says x minus 2, you go 2 units to the right. If it said x plus 2 is 2 units to the left. And then you have vertical compressions and stretches, where you just simply multiply your y values by whatever a is. Okay. Good? Good. Okay. Now we'll look at the standard, what we call the standard form equation. Okay, so when you put those three transformations together, you get this equation for a parabola. So we call it the standard form equation. Make sure you know that's what it's called, because sometimes we'll say, hey, could you give us the equation in standard form? What's the other form that we've been looking up until now?
Y equals y.
It was this one.
Y equals ax plus.
But you guys remember what it's called?
The general?
Yes, this is general form. So now you have another form. You're like freaking Pikachu. And he transforms, doesn't he? Oh, it's an evolution! Okay, sorry.
Sorry.
So general form evolves to standard form. Did that make you guys happy? So what we got on this diagram is basically just a recap of everything. So like the axis of symmetry, there's the vertex. By the way, this form is handy because from this form you can immediately grab the vertex. So if you look here, it says the vertex is at point PQ. Right? So what's that telling us? Because here in the equation it's negative P, and then here it's P. So, oh, we got some examples right away. Like, you have to flip the sign on this when you plug it into your vertex. Why? Because it's always the opposite. Okay? So, the Q value, that is the Y value of the vertex. Whatever value you have here, you got to flip the sign, and that's the X value of your vertex. So we say the vertex is at point PQ. Okay? And then if you have an A value, well, you can deal with that when you draw your graph. Okay? So, for now, let's look at two examples. What's the vertex of the first one? So here it is, standard form. So the X value needs to be flipped. So if it's negative 5, the vertex is actually at positive 5, comma, the Y value is what it is. And remember, your X's always lie, it's always the opposite, but the Y value is always what you see is what you get, okay? Okay. You guys do this one. So what's the X value of the vertex?
-3.
-3, very good. And then the Y value is what it is. Y values never lie.
Wait, hold on.
Okay.
Two negative
What do you got here?
negative 6.
An equation for the image of the transformation of y equal x squared can be determined from the transformations. Yes. So, what we got going on here is we got two graphs. Okay. So we're starting with y equal x squared, which is in red, and then the red one that's dotted is some transformation on that graph. Okay. And what we're going to look at is we're going to start looking at, well, hey, what's the equation of the new graph? Okay? What's the equation of the new graph? So let's see. Let's see if we can track, say, the vertex. So good strategy, so you have to find, a good strategy is track the vertex. So what I mean when I say track the vertex is I mean, well, look at where it started, look at where it ended up, and how do you get there? So for example, for the x values, we started here, and the x value did what? It shifted
1 to the left.
1 to the left. So 1 unit left. Okay? So if you were writing your equation in standard form like they would like, you would start like this. And you could start filling in, well, okay, what happened to the vertex? So that's P and Q. So if I went 1 unit to the left, in the equation,
It's plus 1.
it would be x plus 1. Very good. Does that make sense? That's how you go 1 unit to the left, right?
Mm-hmm.
So you write plus 1. What happened to the y value? Let's see.
Up 3.
So it was here, and now it's here, so it went up 1, 2, 3. Do you guys agree? Okay, so that's 3 units up. So in this equation, it would be y equal a, you can recopy the x plus 1 squared, and then y is what you get. So if it's plus 3, it's plus 3 there. Do we almost have our equation done? What are we missing now?
A or X?
The a value, x and y are placeholders, right? But the a value, we need to have an a value. So I wonder if you guys can figure out how could I possibly get an a value? Because that's way less obvious. Like it's hard to tell, did it get compressed? I don't know. So what could we do? Any ideas? So calculate a value by, anybody? Y divided by x? Oh, like you're trying to figure, no, not quite. No, but you're starting to think in the right direction. There's an easier way, and that doesn't work, but there's an easier way.
Not X2 minus X1.
So we have this graph, right? You guys agree? Could we substitute in a value from this graph and calculate a?
Yeah, we can
Yeah.
take the both points.
Yeah, so pick an xy value. So calculate a value by choosing, I'm just going to say a smart, right, aka easy, xy value on the new graph. Right? Like you have most of the equation. If I could pick an xy value, then I would have one unknown, and I could solve for a. Does that make sense?
Mm-hmm.
Yeah? So what would be a convenient value on this new graph? And by the way, you can't use the vertex because you already used it here. Plugging it in would actually not work. You're going to get like an answer that doesn't make any sense. Well, you'll get 0, but...
Could you use 1 and 4?
And you won't get 0. You won't get 0, but you'll get something that doesn't make sense. Sorry. Huh?
Can you use the Y-intercept?
You could? Yeah. Exactly. Perfect. Yeah. And like, okay, is it always going to be the Y-intercept? No, because you might not have it. But so that's why I say pick a smart point. Like a smart point would be like, well, this one's really easy, right? Like one of the values is 0. I'm just going to switch colors. So what is the Y-intercept here?
It's not 1 and 4.
It's 0 for x, obviously, and 4.
Oh, never mind. I thought the...
Right? Could you have used, I don't know, this point here? Like it looks like it's 1, 7. You could have.
Which one's line 0? Oh, okay. To the right, not to the left. Ah, I see.
Okay, good. So I'm gonna use, in this case, I'm gonna use 0, 4. Okay, I'm gonna pop it in here. So 4 for y, a, x is 0, and then I'm gonna solve for a. So 0 plus 1 squared is 1, so I get 1 times a, so I get 4 equals a plus 3. I'm going to subtract 3 from both sides, and in this case I get a equals 1, which means that there's no compressions or stretches, okay? So my final equation,
Wait, shouldn't it
is
be?
y equal 1.
Wait, it's because 0 plus 1 would be.
It's 0 plus
Did I
1.
make a mistake?
Yeah. And it's 4.
0 plus 1 is 1.
Yeah.
Squared is 1.
Plus
Times
3.
a.
Oh.
And then I got a plus 3, so I subtracted 3 from both sides. I'm
Oh no,
okay?
you wouldn't go like the brackets plus. Oh, never mind. Yeah.
You guys have to be worried. I was like, I hope I didn't mess that up. I wouldn't be surprised if I. But there you go if I did. But there's your equation. You don't have to write the 1. You could write nothing. The point is that you need to show me the work for you calculating a. Okay? So if you go from this and you go to here with no work, I'm gonna be like, well then they just guessed. Okay? You gotta show me the work. Okay? Same thing in grade 12 pre-calc. Like if the question's worth more than a mark, they generally want to see some work. Like if you don't have the work, you won't get all the marks, even if you have the right answer. Okay? Okay. So down here is just sort of the same thing with way less detail, like getting the same exact equation. But any questions? So now we have a lot of stuff under our belt. So we know all these transformations. We know general form. We can graph that. We know standard form, like how to go from here's a graph and its transformation and get the equation. And then we'll do some more. Do some more examples. Okay, so let's just do some more examples with standard form. So this one, determining an equation. So we sort of just did it. We're going to do it again, but for a different graph. Okay, so I'm just saying like, okay, here's the graph, and I want to know what's the equation of this parabola. And I want it in standard form. Okay, so it says by substituting the values of the vertex and one other point, we can produce the equation in standard form. So I'm just reminding you. Have this handy somewhere. Right, so what's the vertex of this thing? Right here. What is that? 3 for x and 2 for y. So that's my vertex. Okay, where am I going to substitute that in? I'm going to put it in here. And let's pick a convenient point. Can I use the Y-intercept in this case?
No.
No, because it's hard. Like if you can't clearly see where it's crossing, don't use it. So they conveniently sort of march to other points. So they're like, hey, look at me. So if I use that one, it might be the easiest because that's the point 1, 4. This is the point, it's the bigger x value, so I don't want to use it. Keep the numbers small. So we're going to substitute in the point 1, 4, and I'm going to write to solve for a. That's why we're doing it, so we can solve for a. For some reason, it seems like half of you will forget to do this on the test. Historically, for some reason. Okay? Hopefully not. Hopefully everybody remembers. But, okay, so let's start over here. So I'm going to substitute in the vertex into my equation. So remember, the x value always means the opposite sign. So if it's plus 3, we write negative 3 there, right? And then plus the q value. So there we go. And now I'm going to sub in 1, 4 to solve a. So y is 4, a is a, x is 1. It might have been easier to plug in the other point. Who cares? Anyways, 1 minus 3 is negative 2. So I'm going to show all my work. I show all my work because it's my notes. Okay. So 4 equals a. In the brackets, I get negative 2 squared plus 2. So that's 4a. So 4 equals 4a plus 2. Alright, subtract 2 from both sides. You get 2 equals 4a. Divide both sides by 4. So you get 2 over 4 equals a. Please reduce the fraction if you can. So you get a half equals a. Final answer, write it out. Here's the final answer. Here we go. Whee! So it's y equals a value. So it's a half x minus 3 squared plus, I lost it, 2.
Yeah.
Boom, you're done. That would be a 3 or 4 mark question. Probably, honestly, I would say it's probably 3 marks. Like I just go 1, 2, 3. Something like that. So getting the vertex gives you 2 marks. That's a good deal. That's pretty easy to do. For getting A, loses you a mark.
That's not a good.
Or having it but not having any work. Okay? Oh, just a reminder, by the way, like, you're not allowed to use your graphing calculator anymore. So you, when we do have a calculator section of the test, I have extra just regular calculators, but yeah. Okay? Yeah, your regular calculator's fine. And it's the same. Why do I do that? Because on the grade 12 pre-calc exam now, you're not allowed a graphing calculator.
Now you're not allowed.
Yeah.
to graph?
The last exam they let you use one was actually in June. So that was the last time where they said on the calculator part, you're allowed to have a graphing calculator. Okay, now it's just like it has to be a scientific calculator. Okay? So I'll do the same so you guys are used to it by grade 12. The 10% of you who make it.
Does the solar panel?
Just trying to worry Chen. Did you hear that? Only 10% of you will make it.
Yo,
I'm just kidding. Okay, what?
the solar panel on the.
Okay, we're going to the next example. Sorry. This isn't your turn. We don't have time. Let's try this. So now we're going to graph it from the equation, of course. And this will probably be your last example. I think I got one more, but what a bummer. Will I have time? Oh, okay, let's go fast. Declan!
No, wait,
We're going to do all this stuff. The vertex, direction of opening, the equation, blah, 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 blah. Okay, can we do this right now? The direction of opening? What tells us that? It's the A value. So it's negative, so it's opening down. The vertex, we can quickly grab that. What's the vertex? Opposite sign for the x. What you see is what you get for the y. Perfect. The equation of the axis of symmetry. Well, that's always the x value of the vertex. So x equal -2. The intercepts, I don't know. How do I find them? So the intercepts would be as in y and x.
You go y equals.
Yes. So let's do some work.
Or no, x equals 0 and then
Y
y
equals
equals.
And you guys are really good, and you're going to label things x-intercept, so y equals 0, right? So let's see. 0 equals, my equation was -2 x plus 2 squared minus 3. The downside of standard form is that you have to do some work to get the x-intercepts. Okay? So standard form easily tells you the vertex, and that's about it. So if I need to find the x-intercepts, I need to do this whole process. So what do I need to do? Do I need to like, what does it look like? Like could
Probably
I,
isolate x. Right?
yeah, try to isolate x. So I can add 3 to both sides. Get this. But you know what? No, we're gonna have to. Is it x plus 2 in here? Oh, we'll see. It could be done. Could be done.
+5.
Yeah, no, we can do this. We can do this. Let's just isolate this. I agree. We'll divide both sides by -2. Everyone agrees?
Yeah.
Okay. So I'm going to get 3. So I'm going to get -3/2 equals. Now remember when we were completing the square and you would sort of get something like this? How did we solve for x? Yeah, perfect. We square root both sides. So at this point we would square root. Now, I'm going to square root this, and that's fine. I would get x plus 2. Can I square root a negative number?
No, you can't.
No. So if I can't, what does that tell me about the
You don't have
x-intercept?
any x-intercepts.
Yes. So you can say can't, square root a negative number. So therefore, there are no x-intercepts. I guarantee you that'll happen to you on the assessment. So expect a question where there's no x-intercepts, okay? Don't get confused and be like, oh, don't call me over and be like, why can't I, what's going on? Because I can't tell you those kind of things on the test. All right. So there might not be x-intercepts, but there still might be a y-intercept, so that's an x equals 0.
There has to be a y-intercept, right?
Yes, and good point, Kevin. We discussed this. There's always a y-intercept. Okay? So for the y-intercept, you plug in x equals 0 here. So you get y equals, gotta do a bit of work here, so 0 plus 2 squared minus 3. So this is going to give me 2 squared, which is 4 times -2, which is -8 minus 3. So my y-intercept is -11. Perfect. Okay. Do I have enough info? I got the vertex. I got the y-intercept. I might need to quickly use a table of values, something to get another point. But I'm going to show you another trick. So let's graph what we have. So we got the vertex at -2, -3. So I'm just going to go everything up by 1. This is a 10 by 10, by the way. So 1, 2, 3. So there's my vertex. Now, this is 10. So I'm just going to go one more tick mark. And I'm going to label that as 0, -11, because that's my y-intercept. Now remember, parabolas are symmetrical. So if you start on this point and go 2 that way, and then 1, 2, 3, 4, 5, 6, 7, 8 down, that's a point. So if I reverse that on the other side, so go 2 this way, then I go 8 down, 1, 2, 3, 4, 5, 6, 7, 8, and that's another point on the graph, okay? What would that point be, by the way? It's on this same horizontal line. What's the y value?
-11.
The y value is -11, and the x value, just look up, well, it's -4. So that's how you avoid using a table of values. You got the 3 points, you got the 3 points. Okay, one to the right, one to the left of the vertex, that's enough. You got all your intercepts, that's all you would be required to sketch the graph. You're done. Okay? So you always need vertex, all intercepts, and then you always need at least 1 point to the right of the vertex and 1 to the left. So if your intercepts don't get you that, then you need to go find more points. Okay, I went a little fast because I was really hoping that we'd have time to squeeze in the last example since I'm recording. So if you have any questions, this is your turn. So same question, different numbers, you can try it out. I want to see if I have some time to do this. So it says using standard form to find the equation from information. So they just say, okay, well here's the vertex and here's a point. Find its equation. Okay? So we sort of already did this actually. Let's skip this one because we already did this one, right? We did a question like this where we have the vertex and then we use this to solve for A. So we already did that. What we haven't seen is this one. So this one might be a little different because I'm giving you the y-intercept. Really, it's the same thing. What's the xy coordinate for y-intercept? If the y-intercept's 2, what's my coordinate? Yeah, 0, 2. Okay, so use this equation in standard form. This is the vertex, so pop it in. So remember, reverse the sign on the x. So if it's +1, now it's -1. And then the q value is what you see is what you get. And now sub in this other piece of information and we haven't used it to solve for A. Okay? So really, there's really nothing new in this question. So for x, I'll plug in 0. For y, I'll plug in 2, and I'll solve for A. All right. So 0 subtract 1 squared is 1. So you get 2 equals 1 times A is A. Subtract 8 from both sides. We get -6. And then just rewrite your equation. And I know I'm going fast. I'll leave it up because I think this is the last thing. You're done. So we did 3 things today. We went over transformations. We saw standard form. We used standard form to draw a graph. We had a graph and we turned it into standard form, and we solved equations with standard form too. So actually that's like 4 things. Okay? Excellent. If we have time, I got a couple like just check your understanding questions. So if the roots of a parabola are 2 and 10, what's the x value of the vertex? Ooh. We talked about this yesterday. Where's the x value of the vertex? Always
In the middle.
in the middle. So remember this equation, x1 plus x2 divided by 2. So 2 plus 10 divided by 2, that's 12. So the x value of the vertex is 6. If the roots of a parabola are -2 and 8, what is the x value of the vertex? Again, same question. So add them up, divide by 2. So in this case, 3. If one root of a parabola is 4 and the x value of the vertex is 9, what is the x value of the second root? Ooh. So in this equation, these are your x-intercepts. This is the x value of the vertex. So we know one root is 4. So I'm just going to write 4 plus some other root. We'll call it x2. And the x value of the vertex is 9. So I'm plugging 9 in there. And then you're solving for x2. What's my first step here?
Multiply each side by 2.
Multiply both sides by 2. So I get 18 equals this. Subtract 4 from both sides. So the other root would have been 14. Nice. There's one more, see if we have time. Oh, it's the same question, just different numbers. So we'll leave it at that. Perfect!